Hello everyone. In this video we will learn about significant figures and scientific notation, and we will solve problems regarding these concepts. What's a scientific notation? It's a method of expressing numbers in terms of decimal number between 1 and 10 multiplied by a power of 10. Like in this example, as you see this number 1.0492, it's a number between 1 and 10 multiplied by power of 10. Here the power is 4. The number which is next to the power of 10, we call it the coefficient. 10 we call it the base, and the power we call it the exponent. What's significant digit rules, and what are the significant digit rules or significant figure rules? Significant means meaningful. It has a meaning. So all non-zero digits are significant. They have a meaning. Captive zeros are significant. What do we mean by captive zeros? Captive here we mean they are in the middle, that lie between numbers, like this 303. The 0 comes in between 3 and 3, so this has a meaning. So it has 3 significant figures. Trailing zeros are only significant if there is a decimal, like here for example. Trailing, it means the zeros that come at the end, like this one 1200, and there is a decimal. So in this case, the zeros here are significant. So 1, 2, 3, 4. This one has 4 significant figures. Leading zeros are never significant. For example, 0.029. These zeros, we call them leading zeros. They are never significant. Exact numbers have an infinite number of significant digits. For example, we can say a triangle has 3 sides. 3 here, it's not measurement, it's an exact number. We are determining the number of sides, which is exactly 3 sides. So here it has infinite number of significant figures or significant digits. In reality, there are rules that governs the calculation with significant digits. We will discuss rules for addition and subtraction, because the same rules apply for addition and subtraction, and another rule applies for multiplication and division. Upon adding or subtracting, we round the answer to the least number of decimal places. Consider these 2 numbers that I want to add. This has 3 numbers after the decimal, this 1 number after the decimal. So the answer should be rounded to the one with least number of decimal places, which means the answer should have only 1 number after the decimal. So when we add these 2 numbers, this is the number I obtain in calculator, but I want the answer to be only with 1 number after the decimal. So I round this up to 7. 5, I will add 1 to 6, it will be 7. Similarly, this rule goes for subtraction. The second rule governs multiplication and division. Upon multiplying or dividing, we round the answer to the least number of significant digits. Like the first number here, we have 3 significant figures, and I want to multiply it with this number. As we said, trailing zeros are non-significant, so here we have 2 significant. So the answer should be written with 2 significant figures, because we take the least number of significant digits. This is the answer obtained in calculator. Definitely we have to round this up, because we want only 2 significant figures. Now let us practice some problems. Convert each of the following into scientific notation, which is a number between 1 and 10 multiplied by power of 10. Okay, we have here 3,427. I wanted number between 1 and 10, so the decimal should be here. But the original decimal is here. Okay, how many times this decimal displaced from the original, because the original is the green one. How many times the one that it should be displaced? Let us see. Displaced 1, 2, 3. This decimal, it's 3 times displaced away from the original one, and the displacement is to the right. So the answer 3.427 multiplied by 10 to power 3, which is the number of displacements. So to the right side, which is from the original. So the one that should be obtained is 3.427, such that it's a number between 1 and 10, which is away from the original, the green one, from the original point. It's away from it 3 displacements to the right. So because to the right, the power here should be positive. What about the second one? The original one, as we can see, the green one is here. I want the decimal to be here, such that it's a number between 1 and 10, 3.1000. So let us count how many displacements we have from the original. So we have 1, 2, 3 displacements. So this one, I will rewrite it 3.1000, keeping the same number of significant figures. Here we have 1, 2, 3, 4, 5. So here should be 1, 2, 3, 4, 5. So this times 3 displacements. So 1, 2, 3. So multiplied by 10 to power 3. Still we have in this calculation times 10 to power of 2. So the answer 3.1000 times 10, when we have the same base, powers are added. So 3 plus 2, which is 5. Part C, again, this number, it's not in scientific notation. I want to change it into scientific notation. The original point is here this time, to the left. I want the point to be here, such that it makes number between 1 and 10, 4.55. Let us see how many displacements to the left here we have. So we have 1, 2, 3, 4, 5 to the left. So the power should be in negative. So 4.55 times 10 negative 5. Again, this is 123,453. So I wanted a number between 1 and 10 multiplied by a power of 10. So the original point lies at the end of the number. I want to put the point here such that it's a number between 1 and 10. Let us see the displacements from the original. 1, 2, 3, 4, 5 to the right. So it will be the power in positive times 10 to power of 5. Again, this one, the original point is here, the green one. I want to put it here. So this time it displaced to the left. So here the left, 1 time displacement, so it should be 10 negative 1, because when the displacement to the left, the power should be in negative. So this turns to be 9.82 times 10 negative 1, and still we have times 10 negative 3. Same base, we add the powers. So 9.82 times 10 negative 4. Second problem, determine the number of significant figures. As we said, the leading zeros are non-significant. So the only significant here, 5, 6, and 5. So here we have 3 significant figures. In this number, everything power of 10 non-significant. So this is non-significant. Here there is point, so I count this 0. So here we have 1, 2, 3, 4, 5. So here we have 5 significant figures. As you see here in this number, there is uncertainty of plus or minus 10. As you see, this number with uncertainty to the tens place. You know, this is the units place, this is the tens place, and this is the hundreds place, and so. Okay, the uncertainty to the tens place here, to the tens place. So I will not count this as significant because there is uncertainty to the tens place, and I will count only till here. So the significant are 1, 2, 3, 4, and 5. So here we have 5 significant figures. Also in part E, this number, we have also uncertainty, but this time to the thousands place. This is the unit, tens, hundreds, and this is the thousands place. So I'm not gonna count this as significant because there is uncertainty for 1000 place, plus or minus 1000. So only these are significant. So this we call it 3. We say that it has 3 significant figures. Dozen of eggs. Dozen, it means there exist 12 eggs. This is exact number, it's not measurement, so simply it has infinite number of significant figures. Square has 4 sides, also 4 here, it's an exact number, so it has infinite number of significant figures. Number 3, convert each into decimal form. Here we have the power is positive, so the point displaced to the right 4 times. So 1, 2, 3, and 4. So the answer 156,000 times 10 to power of 4. Let us recount. 1, 2, 3, and 4. 4, this is the point, this is where it ends. This is the point where it ends. We don't put 0 where it ends. Okay. We have to pay attention that originally we have 3 significant figures. Here, as you see, 1, 2, 3, 4, 5. So there should be uncertainty. I want to count only the first 3. So it will be uncertain to the hundreds place. So plus or minus 100. Plus or minus 100. Okay. Now also this one, but this time the power is negative, so the point displaced 3 times to the left. So 1, 2, and 3. This is the position of the point. So it will be 0.0000209. So displaced 3 times to the left. Why? Because of the presence of negative 3. So now let us see if it's fine. Here we have 1, 2, 3 significant, 1, 2, 3 significant. Okay. The power is positive, indicating that the decimal will be displaced 5 times to the right. So 1, 2, 3, 4, and 5. So this one will have answer 7369 and 4 zeros. But as you can see here, the significant figures are 4 numbers, 1, 2, 3, 4. So I should, all this they are uncertain, which is in the 10,000 place. So I write this number plus or minus 10,000. Number 4, calculate the following and give the answer in correct scientific notation. Okay, when we want to calculate, I have to make sure in addition or subtraction, that the final answer should have as many numbers after the decimal as the least one. Here we have two numbers after decimal, here one number after decimal, so the answer should have only one number after the decimal. If we use the calculator and add these two numbers, the answer is 226.53 times 10 to power of 5. But I want the answer to be only, as we said, one number after the decimal. So 26.5, this one goes down, rounded to 0, times 10 to power of 5. But still, I'm not done yet. Why? Because he wants it in correct scientific notation, so the answer also will change. In scientific notation, this one should be number between 1 and 10. This is the original decimal. I want it to be here. So the displacement from the original one time to the right, so this one will be written 2.65 times 10. Still we have this one, so times 10 to power of 5. I want again one number after decimal, so this will be rounded up. I add plus 1 to 6 and it will be 2.7, and still I have this one and this one, same base, we add power 10. If you don't see power, it means plus 1, so you add plus 1 and plus 5 and it will be 10 to power of 6. Now again, this is subtraction, so the answer should have like the least number after the decimal. Here we have only one number after the decimal, and here we have only one number after the decimal, so the answer should contain one number after the decimal. If I add these two using calculator, I will get answer minus 347. But this is not in scientific notation, so I want to put the point here such that it makes scientific notation later on. The original one is here, so it's away from the original two displacements to the right, so the power should be negative, so minus 3.47 times 10 should be positive, sorry, because it's to the right. But I want one number after the decimal, so this will be rounded, 7 will be rounded, will be cancelled, and we add 1 to the 4, so it will be minus 3.5 times 10 to power of 2. In number 5, I have division, so the rules of division will be governed here, and the answer should be to the least number of significant figures. Let us count. Here 1, 2, 3, this number contains 3 significant figures. This number contains 2 significant figures, so the answer should be up to 2 significant figures. When I divide these numbers using the calculator, I will get 2.633 times 10 negative 4. But I want only 2 significant figures, so I cancel these, I round them down. So 2.6 times 10 negative 4, and now we have 2 significant figures. Similarly, this one, it's division, so I have to count the significant figures and write my answer to the least number of significant figures. 1, 2, 3, 4, so this number has 4 significant. 1, 2, 3, 4, also 4. Okay, so the answer should be up to 4 significant figures. If I divide them, the answer will be 2, but I will write it 2.000 because I need 4 significant figures times 10 to power 17. The last one, this is in multiplication. Also, what applies to division applies to multiplication. Let me count the number of significant figures. So here we have 2 significant, and here we have 3 significant figures. So the answer should contain as the least significant. So the answer should contain only 2 significant figures. If I do the calculation on the calculator, the answer 16.1 times 10 to power 13. This is not in scientific notation. This is the original decimal. I want it here because I want to change it to number between 1 and 10 multiplied by power of 10. So it displaced 1 time to the right, so the power should be positive. And still I have 10 to power of 13. So 1.61, this is 1 plus 13, which is 14. But I want only 2 significance, here 3 significance, so this rounded down, it will go, and it will be 1.6 times 10 to power 14. Thank you for listening.